Hello students, good time to all. I am Chandan Kumar Pradhan. Welcome to your YouTube channel Chandan Physics. In this video, we are going to discuss Colpitts Oscillator. Let's begin. Like Hartley oscillator, Colpitts oscillator is a sinusoidal oscillator, but that one is used in many common circuits, and it is also a LC, or we can say it as tank circuit used as feedback network. To understand its construction, as it's an oscillator, it is the combination of amplifier plus feedback network. Here we take an NPN transistor with common emitter mode configuration, NPN transistor, emitter base collector. In emitter, RE, CE, at base R1, R2, capacitor, at base C of B, at collector use an inductor which is called REC, RFC, radio frequency choke, radio frequency choke, supply the potential, point potential plus VCC, at collector capacitor CFC, the output of that of amplifier at that of collector capacitor. And then tank circuit, LC circuit, we call it as tank circuit. Here the tank circuit consists of two capacitors connected series with each other. That one is C1, this one C2, and these two capacitors are connected parallelly to an inductor having inductance L. These terminals are grounded, and the output is the input towards that transistor, and finally the output we obtained dash the inductance L dash. V output voltage. The construction of Colpitts oscillator. Circuit diagram of Colpitts oscillator. Oscillator is a combination of amplifier plus feedback network. That one is the amplifier NPN transistor with common emitter mode. Here RE emitter resistance connected to a capacitor. That capacitor is called the bypass capacitor. We use bypass capacitor as to neglect the voltage drop across RE. If a voltage is dropped across RE, then power is lost. To avoid such situation, a bypass capacitor is introduced to that of RE. Therefore, that capacitor blocks DC and allow AC. R1 R2 voltage divider introduced to that of transistor to show proper biasing condition. Then at collector, radio frequency choke. That action of radio frequency choke is just opposite to the action of capacitor. In case of capacitor, it allows AC through it and obstruct DC, whereas radio frequency choke allows DC through it and obstruct AC source. Another two capacitors, collector at the base section CB and at collector section C of C. These are called the coupling capacitors, and its action basically for blocking purpose. Blocking in the sense it blocks DC source and allow AC throughout this. Again here in case of CB, it allows AC through this and obstruct DC. This part is amplifier. Next, this is a tank circuit. Tank circuit. In case of Hartley oscillator, that tank circuit consists of two inductors having inductance L1 and L2. These are connected series with each other, and that inductors connected parallelly to one capacitor having capacitance C. But in case of Colpitts oscillator, two capacitors having capacitance C1 and C2 are connected series with each other, and these are connected parallelly to an inductor having inductance L. Basically, if we understand the function of tank circuit, we have to understand how tank circuit functioned. In that of note, if we take, here is the capacitor, an inductor. if that capacitor is charged, one plate positively charged, another plate negatively charged, the positively plate charged capacitor provides the current through that of inductor. Inside that of inductor, a change of magnetic flux occurred, and that change of magnetic flux create an induced EMF, and that induced EMF is just opposite to that of direction of current by using Lenz's law. From positive, first current flows in that direction, and then due to that of inductance mutual induction process, the current flows through this direction, and ultimately that negative end will be positively charged and that positive end will be negatively charged, and the process continued, and we obtain an undamped oscillations. Undamped oscillations, damped oscillations like this, as there will be loss of energy in case of capacitors as well as inductors. To avoid that situation and further feedback is required to that of circuit. Therefore, an amplifier is used to provide the feedback signal to that of undamped damped signal of tank circuit to achieve a proper undamped oscillations. As we know, if we provide a signal like this at output of that of amplifier, as we use common emitter NPN transistor, the output we obtained 180 degree phase shift, to achieve the sustained oscillations. It has to be obeyed Barkhaussen's criteria. What is Barkhaussen's criteria? The total phase shift throughout that of entire loop either 0 or integral multiple of 2 pi means 360 degree. It is a phase shift of 180 degree. So, further phase shift 180 degree additional needed, and that additional phase shift was provided by that LC circuit, or we call it as tank circuit. It provides further phase shift. (180 degree). And finally, at output we have the amplified signal with 360 degree out of phase. Here 180 degree phase shift, there 180 degree phase shift, the output we obtain 360 degree phase shift. So at output we obtained a sustained type of oscillations. We can understand that working as when voltage plus VCC is applied to the capacitors C1 and C2, these two are charged. When these capacitors are fully charged, they discharge through the inductor L and oscillations are produced. As I clear it by taking a note, when the capacitors are charged, they discharge through that of inductor L and oscillations produced. The oscillations across C1 are applied to the base emitter circuit of the transistor and appear in the amplified form in the output circuit, that is provided C1 to that of base emitter junction, and output we obtain the amplified version. The output oscillations of the amplifier appears across C2. The output amplified versions appears across C2. The oscillations across C2 are feedback to C1 by the C1 C2 voltage divider. That is the feedback to C1 through that of C2 by that of C1 C2 voltage divider. The transistor provides a phase shift of 180 degree between the input and the output to voltages. Input and output we have 180 degree phase shift, and a further phase shift of 180 degree is provided by C1 C2 voltage divider. Further phase shift 180 degree required, and that further phase shift provided by that of C1 C2 voltage divider, which one is 180 degree. Thus the net phase shift around the loop 360 degree, 180 degree plus 180 degree, 360 degree. In this way the circuit provides a positive feedback to produce a continuous undamped oscillations in the tank circuit, and output we have continuous undamped oscillations. That is all about construction as well as working of Colpitts oscillator. So what be the frequency? Therefore frequency of that oscillator is the frequency of the tank circuit. Here the expression of frequency of tank circuit 2 pi under root of LC. In case of that type of tank circuit, C1 and C2 are connected in series. Therefore as C1 and C2 are connected in series, so the net capacitance that is 1 by C is equal to 1 by C1 plus 1 by C2, or 1 by C is equal to, taking LCM, C1 C2 C1 C2 plus C1, or net capacitance C is equal to C1 C2 divided by C1 plus C2. that value we can put here. The frequency of that particular oscillator nu is equal to 1 divided by 2 pi is 1 divided by L in place of C, C1 C2 divided by C1 plus C2, its under root, or nu is equal to 1 divided by 2 pi C1 plus C2 divided by L C1 C2 under root. That will be the expression for frequency of Colpitts oscillator. Next, the advantages, disadvantages and applications of that type of oscillator. Advantages: it provide good wave purity. In case of Hartley oscillator, at output we obtain harmonic oscillations, means we can't obtain a pure form of sinusoidal wave, but in case of Colpitts oscillation, the purity of wave is good. It is a fine performer at high frequency. At high frequency, it acted well. It provides good stability at high frequency, and it has a wide frequency range of operation, that is around 1 to 60 megahertz. In these 3 points, it conclude at high frequency it works better. Frequency stability of Colpitts oscillator is better than Hartley oscillator. It has a simple construction: one amplifier, one feedback network. Feedback network is a LC, that is a tank circuit. In tank circuit, 2 capacitors and 1 inductor. Next, disadvantages: it is difficult to adjust the feedback because it requires change in capacitor. Here the capacitance, varying capacitance, so it is difficult to adjust the feedback due to that reason. Next, it is difficult to select the values of C1 and C2 because higher values of C1 provides more output and higher value of C2 provides better frequency stability. These two are the disadvantages. As the frequency, as C1 and C2, the capacitance are varying. Therefore, in case of feedbacking situation and proper frequency stability, it's not more convenient to use. So these two are the disadvantages of that type of oscillator. Next, applications: it is used as a high frequency generator, also used in microwave applications, used in mobile and communication systems, used to generate oscillations ranging from the frequency audio frequency to the frequency of optical band. These are some applications of Colpitts oscillator. So here, with the help of this video lecture, we understand the concept of Colpitts oscillator, its construction, working, frequency of that particular oscillator, advantages, disadvantages, and finally applications of Colpitts oscillator. So, with this useful and informative notes, let me wind up the session. Thank you.